In this video, we'll be talking about section 6.3 of your text, which deals with working backwards with the normal curve or inverse normal curve problems. In previous problems, we were given z-scores or values associated with the normal distribution and asked to find a section of area. Now we're going to be given sections of area under the normal curve and have to find the corresponding z-scores or values. In previous problems, you would be given some z-score, and then you would be asked to find, let's say a particular section of area, something like this. In these problems, you're going to be told what the amount of area is, but not what the z-score is, and that's what you'll have to find. So here's how we solve backwards normal curve problems. First, draw a picture of the normal curve, shade in the specific piece of area the problem has given you, and identify what z-score or value you need to find. Make sure to pay attention to if this z-score is supposed to fall above the mean or below the mean. Second, figure out what area to look up on the table and convert any z-scores back to values relevant to the problem if needed. If you're using the calculator, you need to identify the amount of area to the left of the value you want to find, and we'll talk more about this when we get to specific calculator directions. Here's an example. If we found an area of 0.4744 on the z-table, what z-score did we look up? So all of these in here are areas, and they're telling us we found an area of 0.4744. So if we look around in this table until we find that amount, and here is 0.4744. So if we found this area, and if we follow it backwards, we see we have z is equal to 1.9. It's over here, and then if we go up, we'll get the next digit. So if we were to look up, z is equal to 1.95. We have 1.9, and then we go over to 0.05. This is the area we would get. So if we had been told in a problem we had the amount of area between 0 and some mystery z-score was equal to 0.4744, we could use this technique using the tables to see that this z-score is equal to 1.95. Here's another example. Suppose the percent of data under the standard normal curve between z is equal to 0 and z is equal to question mark. So we don't know what it is. So we have 0, and then we have our unknown value is 0.4452, or 44.52%. We want to find the corresponding z-score. So we know what this piece of area is over here. We need to find the z-score. Now the way this z-table works is it gives us pieces of area between the mean and some positive z-score. So we'll try to find this value on the table or the closest thing as possible to it, and that's right over here. So we have 1.60. Now we'll talk a little bit about how to solve these problems using the TI-83 Plus calculator. So to have the calculator solve these problems for you, your calculator needs to know the area below or to the left of the value you're looking for. In the last example, we were told the amount of area between 0 and the unknown z-score was 0.4452. But the calculator needs to know all the area to the left or all the area below the z-score in question. So that's where we need to remember this half of the curve is 0.5. So the total area to the left would be 0.9452. So what you would input into your calculator in this case, you would hit second, then bars, pick the third option, which is inverse normal, hit enter, then you want to input inverse normal, the area to the left, which in this case is 0.9452, and then your mean and standard deviation. In this problem, we were dealing with the standard normal curve. If you're dealing with something that's not standard normal and they give you a different mean and different standard deviation, that's where you would put those in. So you input this into the calculator, you end up getting 1.59999, which rounds to 1.6, which is, close to what we had before. Let's look at another example. Here we want to find the z-scores associated with the middle 46.48% of the data. The first thing we need to do before we can figure out how to use the calculator or the tables for this is draw a picture. So they said middle chunk of data, so that means we have a negative z and a positive z. Again, remember the curve is completely symmetrical, and this is the area they're giving us, and we know this whole thing is equal to 0.4648. If we were using the tables, we can't just look up 0.4648 because the tables will only give us pieces of area that are between 0 and some positive z-score. So we could figure out what this piece is from the tables, but not this middle piece like this. But luckily, because the curve is symmetrical, we can figure out what each of these halves is. If we take this area and divide it by 2, get 0.2324, and that's the amount in each half. So this half is 0.2324, and this half is 0.2324. So this is what we're going to look up on the table. And 0.2324 falls here, so we have 0.62. So that's our positive z is going to be equal to 0.62, and our other z, keep in mind we do have a negative z-score, that's going to be equal to negative 0.62, again because the curve is completely symmetrical. Now if we were to solve this using the calculator, we need to know the area to the left of any of the z-scores in question, and we do have two z-scores here, so we have our first unknown z-score over here. We would still need to determine that this piece is 0.2324, but then we need to know this piece is 0.5. The area to the left of the positive z-score is going to be 0.5 plus 0.2324. Mean is 0, standard deviation is still 1. We put this into the calculator, we end up getting 0.62008, which again just rounds to 0.62, which is the same as what we got before. But we also have the negative z-score. Now if you know the curve is totally symmetrical, you'd know these two z-scores would be the same, just opposite in sign. You could realize the other one is negative 0.62. But if you wanted to get it directly from your calculator, you'd have to do it a little bit differently. So we know this piece here is 0.2324. This is the piece associated with the negative z-score. The calculator would need to know what this piece of area is over here because this is the area to the left. So this piece is 0.5 minus 0.2324. So what we put into our calculator is inverse normal, 0.5 minus 0.2324, 1, and we end up getting negative 0.62008 or negative 0.62. So these are our two z-scores. Let's look at another example. Here we're being asked to find the z-scores associated with the upper 10% of the data and the lower 10% of the data. So up here, this is our upper 10%, and this is our lower 10%. So we want to find the z-scores associated with this. Now, if we're using the calculator, this piece right over here, we already know the area to the left, so on the calculator this would be inverse normal. Our area to the left of the unknown z-score is just 10% or 0.10. Mean is 0, standard deviation is 1, and we end up getting negative 1.28155, which just rounds to z is equal to negative 1.28. Now, if we wanted to figure out what the area to the left of the upper 10% is, we'll draw another picture and we'll just focus on the upper 10%. So this piece over here we know is 10%. We don't know what this z-score is, but we do know that the entire area under the curve is equal to 1. So remember, both halves of the normal curve have an area of 0.5. If we add these two together, the total area is 1. We can also use the fact that the total area is 1 to figure out what this area to the left is. So everything over here is going to be equal to 1 minus 0.1, which is equal to 0.9. So to find this on the calculator, we would do inverse norm, 0.901, and we end up getting positive 1.28155, or z is equal to positive 1.28. Now we'll talk about how to find these from the tables. Okay, so we know that this piece of area over here is 0.1. Same thing for this piece of area here. Now we can't just look that up on the tables. We can find stuff pretty close to it, like 0.0987, 0.1026. They're pretty close. But remember, these areas in here correspond to the unshaded regions like this, where it's the piece of area between 0 and some positive z-score. This table does not tell you what upper tail ends or lower tail ends of area are. So in order to figure out what these z-scores are from the table, we need to know what these unshaded pieces are. And in order to figure out what these unshaded pieces are, we would subtract the shaded area from 0.5. So this piece has an area of 0.4, and so does that other piece. But we can only look up 1.4, and then we have to remember this would correspond to a positive z-score over here for the upper 10%, and it would correspond to a negative z-score here for the lower 10%. So we will try to find 0.4, or the closest thing we possibly can find to 0.4. So the closest thing that we can find to 0.4 is 0.3997. There's also 0.4015, but that's a little bit further away from 0.4. This is closer. So if you can't find the exact value, you want to pick the closest possible value that you can find. And okay, so the closest we found is 0.3997, which corresponds to z is equal to plus and minus 1.28, which is the same thing that we got before. So here's one more example. We want to find the z-score associated with the upper 90% of the data and find the z-score associated with the lower 90% of the data. So our upper 90% is going to look like this. Okay, so this is our upper 90%. Now we know that this piece of area looks like this because, again, remember, you have 50% of the data above the mean and you have 50% of data below the mean. So if you're dealing with an upper percent of data that's less than 0.5, it's going to be an upper tail end. If you're dealing with an upper percent of data that's greater than 0.5, it's going to have to reach over into the lower half in order to be greater than 0.5. So this is a piece of area we have, and we need to know the amount to the left. So the calculator needs to know what's in this unshaded piece over here. And in order to find that piece over here, we can minus 0.9 from 1, and we end up getting 0.1. So now this becomes the same type of problem that we had before. The z-score associated with the upper 90% is going to be the same as the z-score associated with the lower 10%. So this would just be inverse normal. We would have 0.1, 0, 1. You also could have inputted like this. 1 minus 0.9. It'll give you the same thing. Which is, again, z is equal to negative 1.28 after you round. Now we'll see what the picture would look like for the lower 90% of the data. So the lower 90% of the data is going to be here. So it's the 90% that reaches into the lower half of the curve. Okay, so these two pieces together give us 0.9, and this is already the amount of area to the left. So if we put this into the calculator, we just put it in as is. And that's going to give us z is equal to positive 1.28 after we round everything. And just note, this is the same z-score that's associated with the upper 10%. So this unshaded area over here was the upper 10%. Just like this unshaded area over here was the lower 10%. Now we'll take a look at how to solve this using the tables. So for our upper 90%, remember that looked like this. We know this has to be a negative z-score. We can't just look up 0.9 on the table. The table doesn't even go as high as 0.9. The highest we can get over here is 0.4998. It never goes that high. Again, we need to find a section of area between 0 and either a positive or negative z-score, again, because the curve is symmetrical. So we want to find the area in this piece over here. So now we have to keep in mind that each half of the curve is 0.5. So this piece has an area of 0.5. we can use that fact to determine this piece has an area of 0.9 minus 0.5, which is equal to 0.4. So we'll look for the closest thing we can find to 0.4 on the table. It ends up being 10.3997, which corresponds to 1.28. Now it corresponds to positive z is equal to 1.28, but we have to look at our picture to determine this z is supposed to be negative based on where it's placed on the graph. Now the other one they wanted us to find is the z-score associated with the lower 90% of the data. Now this is essentially the same problem. It's totally symmetrical. Our graph is just flipped around. So we have some positive z-score over here. We know this whole area is 90%, but we can't look up 90% on the table. We would need to find this piece over here, which this piece over here is 0.9 minus 0.5, which is equal to 0.4. And we would end up looking up again the closest thing to 0.4000, which gives us z is equal to positive 1.28.